In this video, we look at some arithmetic with functions again, as it relates to what's called the difference quotient. And you're probably thinking quotient means divide. So yeah, we're going to have a fraction here, unfortunately, for some of you. But hopefully it's not too bad. The difference quotient, let's define it just in case it helps anybody understand it better. Sometimes people overlook what this means and just memorize it, and that's fine too if that's what you need to do. I always like to understand something that I'm working on if I can. So the difference quotient is simply the slope of a function between x and x plus h. Okay, so if you've seen slope before, it's one y value minus another y value over one x value minus the other x value, and that's exactly what the difference quotient is, except that we're dealing with a function. Let's say the function is f of x. Okay, so the difference quotient, and by the way, this topic is really heavily used at the beginning of a standard calculus course. So if you're planning to take calculus, this will be really important to you. So what you have is a fraction. You're going to have a y minus a y. Now the first y is the y that you get for this x value. These are x values. When you have a function, the way to calculate a y value is to plug this thing into the function. So that would be f of x plus h. So that y value. And the y value for this x value is simply f of x. So what we get is f of x plus h, the bigger y value, if you will, f of x plus h, that's your first y value, minus your smaller y value, f of x. So these are y values here. And of course these are x values. Okay? And then on the bottom you take x minus x. So I'll take this first x, the bigger x if you will, again, x plus h, minus the second x value, x. Now you could certainly leave it this way, and I really do think this is the easiest way to remember this if you're familiar with slope, y minus y over x minus x. Same thing here, y minus y over x minus x. The top, those are y values because you're taking f of something, so those are y values, those are outputs of functions. And you can't do anything to simplify the top without knowing more, but there's no f on the bottom, so you can do some work on the bottom just to clean this up, and it's typically presented this way in textbooks. The bottom is simply x plus h. You can drop the first set of parentheses because there's like a hidden 1 there that you can distribute, minus x, which of course you don't need parentheses as well. And x minus x is 0, so on bottom you simply get h. So this is how the difference quotient is typically presented in textbooks. Okay, so you do need to know what the difference quotient is. It comes from, and by the way, I certainly think that this is the best way to remember it because you can always get to here. It's just slope is all it is. Okay, so pick one or the other. Personally, I think of this and then I simplify it down to this. Okay, but now let's do an example where we actually determine a difference quotient where we have a formula for our function, a specific function. So let's give that a shot. So now we need to find the difference quotient for this guy. So my x values are x plus h and x. I already know that. I know f of x. What I need to know is f of x plus h. So first of all, let's write out what the difference quotient is. It's the bigger y minus the smaller y over the bigger x minus the smaller x, which of course simplifies down to just be h. Okay? Now what I need to know f of x plus h. So let's go to the side and write out what f of x plus h is. F of x plus h means plug x plus h in as the input to my function, which is right here. So I get x plus h squared minus x plus h minus 4. Now I need to simplify this down, and when I square x plus h, that means multiply x plus h by itself. And here I need to distribute my negative to get minus x minus h, and then I copy down my minus 4. Now I distribute my x, I get x squared plus hx. Distribute my h and I get hx, and I get h squared. And then I clean it up if I can. I can't combine, there are no other x squared terms. I've got one hx plus one more hx, giving me 2 hx. I don't have any other h squared terms, no other x terms, no other h terms, and no other constant terms. So this is f of x plus h. Okay? So I can come back over to my main problem, and I can replace this yellow guy with all of that. I know it looks messy, but don't get caught up in the details. It's just that thing, the whole thing, so I put it in parentheses, minus f of x. So I need to know what f of x is. Well, f of x is right here. So minus all of that, divided by just h. Okay? So now I've actually calculated my two y values on top, and I just clean it up. So I can, again, there's like an invisible 1 out here that I can distribute, so those parentheses just drop off. This negative distributes. That's why the parentheses here are so key. If you don't put those, you won't know to distribute the negative. It applies to this whole thing. So I get minus x squared plus x plus 4, and that's all divided by h. And then I just combine like terms on top. So my x squared and my negative x squared give me 0. 2hx doesn't combine with anything. I don't have any other h squared terms to combine. I've got a negative x, but I've got a positive x that gives me 0. And I've got a negative 4 and a positive 4, which gives me 0. So I'm left with 2hx plus h squared minus h on top. And on bottom I just have h. Now I notice I'd like to be able to cancel on this fraction if I can, but to cancel in a fraction, you may remember you have to factor first. And on the top, each of the three terms contains an h. So I'm going to pull that common h out, my greatest common factor of h I'll pull out to leave 2x plus h minus 1. So I pulled an h out of all three of those, and now that it's factored, h divided by h is 1, so those cancel to give me 1, leaving me with my final answer of 2x plus h minus 1. So that's my difference quotient. Okay, lots of details here, but really the key is getting started. You need your bigger y value minus your smaller y value divided by the bigger x minus the smaller x, leaving you just h when you simplify that. Okay, let's try one more. Here our function is g of x, so our difference quotient is going to be g of x plus h minus g of x, my bigger y minus my smaller y, over my bigger x minus my smaller x, but then those x values cancel, leaving me with just h. And so again, I need to know g of x plus h, and it's not given here anywhere, so I go off and do some side work. I like to do this as side work to keep this part over here as clean as possible. So g of x plus h equals, I go to my g formula and I plug x plus h in for the x. So I get 2 plus 3 times the absolute value of x plus h. And I can't simplify that at all, so that's it. So that's my g of x plus h. That's the yellow guy over here. So I write that whole thing, don't forget your parentheses, minus g of x. Well, g of x is what's given to us right here, 2 plus 3 times the absolute value of x, and I need to put that in parentheses as well, all divided by h. Now, I can drop my first set of parentheses, because there's that 1 in the front that we can't see. I distribute my negative, giving me minus 2 minus 3 times the absolute value of x. And now that my parentheses are all gone, I can combine like terms on top. So I've got 2 minus 2 giving me 0, and I can't do anything else. So I've got 3 times the absolute value of x plus h minus 3 times the absolute value of x, all divided by h. Now my two terms on top, neither one of them has an h factor, so I can't pull it out. So I'm done. I can't factor out an h and cancel. So this is my final answer. This is the difference quotient for this function.